Hi friends, very good morning. Welcome to Anu Academy. Very good morning friends. Today's class in our channel we are going to discuss mechanical measurements and control systems subject. In this subject we are going to discuss the most important topic, that is transducers in measurement. Okay, I will repeat it once again. Today's in our class in our channel we are going to discuss mechanical measurements and control systems. Okay, in this subject we are going to discuss most important topic, transducers in measurement. Okay, so if you are getting a question in this class, we will discuss if you are getting a question in your examination, how to write the answer. Okay, so basically it is a theory question. Once we are getting a theory question, how we can give a good presentation so that the examiner can understand our subject, and at the same time we can score good marks. So this video, this class will be helpful for you for getting good marks in your examination. Okay, so let us start today's class. As I told you, today we are going to discuss transducers in measurement. Okay, right, now material is ready in front of you. We will start discussing transducers in measurement. Okay, right, a transducer is a device to convert position, displacement, thermal and optical signals into electrical quantities that may be amplified, recorded and otherwise processed in the instrumentation system. So once you are getting a question regarding this transducers, write a small definition or write a working of this transducer. Next, classification of transducer. Based on the head of the transducer, the transducer classification are of four types. First is the self-generating analog. Second is variable parameter analog. Third is pulse or frequency generating. Fourth is the digital type. Next, voltage and current generating analog transducers. Transducer of this type require no outside source of input power for operating. These transducers are based on certain materials and devices which generate the voltage with light, radiation, heat or mechanical forces or stresses, etc. Okay, next, self-generating transducers. What are the how many types of self-generating transducers are? So starting with piezoelectric transducer, second is thermoelectric transducer, third is magnetoelectric transducer, fourth is electron tube transducer, and fifth is electrokinetic, and last is the radioactivity. Okay, so here this is the principle how does a transducer works. So this is the transducer. Here it is passed to the signal conditioner and indicator or recorder. So this diagram compulsory you have to draw for the transducer in measurement, and heading for this diagram is the working principle of a transducer, or we can say self-generating transducer. Right, so today's class we will discuss about as I told you, this transducers. In this class we will discuss the working principle of a piezoelectric transducer. Okay, so if we observe our previous year's question papers, I think we can find each and every question paper we can find this piezoelectric transducer question. Okay, so that's why I have selected this piezoelectric transducer. Now we will see, first we will understand the diagram of this piezoelectric transducer. Okay, so first thing is we have to understand the diagram, its parts, what are the parts, how the parts are working, right, and entire setup is based on which working principle. These things we have to understand properly. So once we understand these things properly, we can draw the diagram without any errors. Okay, right, now we will see what are the important points are there in this diagram. Okay, so this is the entire setup of this piezoelectric transducer. So here this is this direction, this we can say it is a piezoelectric resistor with Young's modulus E and charge sensitivity S. Okay, So the main part of this diagram is the piezoelectric crystal. So this is the crystal, and continuing this diagram, this is the force, direction of the force, and these are the two electrodes, right? And this is the output voltage. Okay, this is the output voltage, this is the length, and this is the width of the diagram, and this is the T, this is the delta T of this diagram. Okay, now we will see how we can understand this piezoelectric transducer in depth, right? Okay, right. There are certain substances which generate voltage when they are subjected to mechanical forces or stresses along specific planes. Mechanical force can be sensed into electrical signal which operates an indicating device. These substances are generally crystals, natural and synthetic. Okay, so in this diagram we have seen this is a crystal, okay, piezoelectric crystal. So these crystals are of two types. First is the natural and second is the synthetic type. Okay, right. Both the types are temperature and humidity sensitive. These are mainly used in the study of extremely high speed phenomena such as explosions and blast waves. Now we will understand exactly what is happening with this piezoelectric transducer. Okay, see, with the help of this piezoelectric transducer, see, first force is subjected to this crystal with the help of the electrodes. So this force is passed to the crystal. So once the force is passed to the crystal, what is happening to this crystal we have to observe carefully. Once force is passed to this crystal, what is happening here to this crystal, right? See here, electrical neutral, we can observe electrical neutral, and atoms are arranged unsymmetrical. Okay, atoms of the crystal are arranged unsymmetrical. So once atoms are arranged unsymmetrical, what is happening to the electrical charge? Electrical charges are balanced. Okay, electrical charges are balanced. So once electrical charges are balanced, what is happening? The crystal deforms, and we can see net positive and net negative get induced. Okay, so once crystal gets deformed, what is happening here? We can see net positive and net negative get induced. So these things you have to understand, especially about the piezoelectric transducer and what is happening to the crystal, right? Right. Next, we can see some advantages. Definitely, you will get a question regarding the advantages of piezoelectric transducer. So these advantages you can it is for the high speed phenomena such as explosions and blast waves. This is because of their high transient response that they are able to detect events of microseconds, and output is linear. So these advantages you can write, but disadvantages is low output, and sometimes crystal will break. So these advantages you can write for this piezoelectric transducer. Okay, so that's all friends for today's class. I think this class will be helpful for you for getting a theory question, how you can give a good presentation in your answer sheet so that the examiner can exactly understand your subject and your presentation, and you can get good marks. Okay, so if you have not subscribed our channel, please subscribe our channel. Please like and share our channel. Please discuss with your friends the class for going on in our channel. Thank you for watching.